Have you seen such patterns while taking photos on your smartphone? When you walk from a bright interior to the dim outdoors at night, the camera UI automatically turns on night mode. And now, if you press the shutter, it is necessary to wait for a second or two for the image. How do smartphone cameras tell the difference between day and night, or switch modes according to brightness? This is because the cameras can smartly detect light. Photography is capturing information about light. Light is projected through the lens and then to the sensor. The sensor converts the optical signal to a voltage of different strengths according to the intensity of the luminance information collected by each pixel. For example, the highlighted area of this photo is due to the high light intensity, which means that the voltage converted is stronger. Then, the RGB values of these pixels can be obtained through the Bayer filter array, which arranges RGB color filters on a square grid of photosensors. Therefore, in a dim light environment, the voltage converted by the sensor is generally lower, and the RGB value of most pixels is closer to zero, so the camera naturally knows it is dark. How can we teach the camera to identify specific scenarios based on its ability to distinguish between day and night, like this and this? As we also mentioned in the last episode of Xiaomi Academy, with the help of computer vision, computers can learn to imitate the human visual system and distinguish people, objects, and landscapes through many samples. A combination of intelligent exposure and computer vision in smartphone cameras can have many different functions. To achieve this, engineers utilize deep learning by collecting photos and their corresponding exposure parameters, such as shutter speed, ISO, and aperture. This information is then categorized according to the scenario. Parameters such as brightness and contrast are manually adjusted to match human aesthetics to be used as samples for model learning. With the help of computer vision, smartphone cameras can then identify scenarios with hundreds of millions of samples. Moreover, it can also match the appropriate parameters according to the reference information. For example, when we take portrait photos facing the sun, the background is often overly bright, or the person needs to be more balanced in the original scenario with an appropriate brightness. The camera now identifies the sun and person in the scenario, and the subject is dimmer than the ambient light. The camera automatically turns on the HDR, selects several photos with different exposures, and extracts details that can fuse into a clear image. In low light, algorithms are more involved in photo optimization. Photos without algorithmic processing will always suffer from multiple problems, such as low brightness, color distortion, and severe noise in night scenarios where light is extremely dim or with different light sources. The algorithm can effectively adjust the brightness on parts of the photo and enhance its dynamic range to improve overall brightness. The algorithm can also deal with color distortion by distinguishing the light source and restoring the scenario's original color. Furthermore, it can achieve super intensity denoising, resulting in a clearer image. On this basis, Xiaomi also brings the Ultra Night Photo algorithm. The algorithm intervenes when you press the shutter. Based on AI alignment, intelligent frame selection, AI denoising, and other algorithms, the content of multiple long exposure photos is aligned to reduce the impact of slight movements while photo taking. It uses multi-frame information to get rid of noise effectively. Then it will brighten the image areas of different scenarios with algorithms such as AI brightening and AI color restoration. More brightness information will be retained while restoring the color of the image. You can get a night photo with precise details, true colors, and clean images through Ultra Night Photo. In addition, Xiaomi's self-developed night algorithm was highly recognized in the CVPR 2022 New Trends in Image Restoration and Enhancement Workshop and Challenges, and finally won the World Championship in both the public and photographer's choices. For Xiaomi engineers, coding is a form of expression. Mobile imaging algorithms will go toward faster and clearer photos, more authentic colors, and a higher dynamic range. Computers will also solve other complex issues, such as color recovery in multicolor temperature scenarios and capturing moving objects in dim light. As hardware and algorithms improve, image quality algorithms will increasingly be applied to smartphones. AI will continue to be a core force in advancing mobile imaging. We will continue to explore technologies that bring happiness to everyone's life.
Xiaomi.